Hello, this presentation is to talk about soil and water bioengineering techniques. The, the soil and water bioengineering techniques is based on the use of some plants that has different properties that human can use. And what we are going to talk today is about the property of these plants to control the soil and to retain sediments and retain slopes in order that can be resistant against flooding, also against slides. This technique is very old. Here you can see Leonardo da Vinci talks, but the modern origin is between the First and the Second World War. Schiltel is an Austriac engineer because they don't have nothing to repair the problems they have in the Alps. They begin to create soil engineering techniques with some calculation. So this is the beginning of the scientific or technical soil engineering. The base of the soil engineering are plants. And in rivers, what we do is we select which plants are the more convenient for do the jobs. Not all the plants works. Of course, when you select a plant, you should select things like weather, the slopes, lithology, things that can change the species. From here, you can select a list. And also, we used to work always with autochthonous plants. These plants also sometimes, because where there are problems are related with humans, we take care about landscape and, of course, about the capacity of these plants. This means a list of suitable species, and sometimes these species can protect a slope, can keep a slope in place, but when they are well developed. For being sure that when we do a work, it is active from the minute zero, we use a technique of soil bioengineering. Okay, not all the plants are useful. We select plants that there are plants in rivers, for example, that the idea is that they prefer to be washed away, and in the place they go, they begin to grow again. And we are more interested in the plants that resist. The first thing that we need to know is the relation of the upper part and the roots. And you can see, for example, here, Salix alba has a very low proportion of roots and a lot of upper part. That means that this tree is not useful because can be fall apart. And apart from this, we always try to work with the shrubs and herbs because we don't want to create the final combination of plants, no, the ones that are in the surroundings. We use the plants that are more technically useful, autochthonous always, as I said, and we see that the tensional strengths of the roots and of the trunk are okay. That has the action of consolidating the soil because of the root system, and also have the capacity to create soil. Normally, when we do a work with in several years, all the plants, all the trees, all the woods that are in the surroundings appears colonized, and you can see any difference between what we have done and the rest. We are going to explain a little bit more in detail what's going on, and I begin with hydrophytes. There are some hydrophytes that has a great capacity to protect the slopes, especially the banks of the rivers. But of course, if we introduce a plant like this and we tell someone that this will protect him, nobody will believe it. So what we do is create things every time more sophisticated, with the idea to have something very well vegetated that can these plants are already developed. So when you install there in a few days, the roots go down and fix. So these are techniques to be sure that everything works. Two ideas here, for example, is Anidis pseudocorus, and the roots not here because this is in a container, but the root can do 3 meters depth, So it's very good to keep a bank under control. And another example is here, there are some plants. It is also pre-installed. We do it in a nursery and then we plant this. And we have done several, well, hundreds of works with this material. And we have studied what's going on. And we discovered that, for example, from the real events that they get, floodings, we find that we can for sure know that this resists 5 meters per second of the speed of the water and tensions more than 300 newtons per square meter. This is not the top, it's just the one that we can, that we have data. So it's really a resistant material. And here, one job, here, always the idea is you select some plants, no? And the plants are the most important thing, and then you select the way you can install the plants. This is a very special job because it's in the agricultural land, in an irrigation channel, and the idea is how we can protect the slopes. So we create different techniques, from the more simple ones that is just planting, for planting with coconut netting, and then with pre-vegetated pallet, a fiber roll, etc., etc. No, so different techniques. And here is the place that we want to work. Here, sometimes they install stones, but the stone creates also erosion behind, so don't works. So the only way they thought in the beginning was concrete. And what we do is we select these plants that don't grow a lot, so don't make shadow to the land, so it's not a problem. And the result is like this. In that case, what we notice is that all the plants can grow easily and we don't have to reinforce it, but always depend in the events of flooding that are before. And one special place important is here. When you have a rigid one, you have local erosions, and you should control a lot this. You can see that we have done this and looks great. More samples of the same idea. So that means that in this land, agricultural land, we can protect the slopes of the channels with a natural thing that improves the quality of water and don't make shadow to the customers, to the people who is working there. This is another example of in Samboy with also work with the lofits. Here is this shrubs I show, and this is a dam of soil because this is very dirty in the past and they prefer the people from the street don't see this. So what we do is we clean it, we install vegetative fiber roll or rock, and this is what it looks like. And then of course they take out the dam, they make a place to walk, and this creates this nice habitat. Another example that we begin to introduce now as shrubs is a next level. The idea is when a shrub, in that case salix, can grow in good conditions, we create a system that is for being sure that anything that happens in the area before the plant is well developed don't affect the stability of the slope. So in this case, we create this slight growth. Here you will see how it's finished with the planting. Here a few months after, and how it looks it now. One special thing here is this work is in the Mediterranean area. We had very heavy flooding, so this has been flooded several times now. And here there is a park area, and you can see here some coir logs, fiber rolls. So these are prepared for collect the water of the park area. In the down part you have the river, so you have water, but in the upper part can be very hard in summer. So making this system, we collect the water, we clean this water, and we have water to make it grow. That means that every place has details to be considered. Another work, this is a footpath with some erosion. So we make, in that case, is like a wall of trunks, but these trunks are vegetated. The idea is this system, that this has a very great capacity. We have we know that some of our work resist more than 500 newtons per square meter real from the storm. So this is very, very secure, and it is really a box. Here only show the face, but it's a box. Here's the details of the end, how it looks like after some month and after I think 10 years. This is absolutely natural, and you can see also, if you don't know that there is something there, you don't notice. Another job that is here is a very good sample that what we do. You see that this is behind the level of the river, because our engineers look at the transition erosion, what happens when a flooding comes, some soil puts in movement and then return to the same place. So you don't see any difference, but there is a difference in the stability of the slope. So we go behind, we install some gabions on the top, and here is and we plant and we put this in that case fascines or this, to be sure that the soil of into the box don't gets out. Here is how they make. Here is what it looks at the end. Look at that, here there is a hole because the sediments will come there. You don't need to do things, and this is how it looks like in the first the first time that rains. And I want to show you now what happens. This is in the same place. This is just 1 week after that. The mayor of the town and the engineers of the town that don't know these techniques was a little worried about what's going to be. This is the first job of a big job in a big area. So what I have done is ask a lorry full of rocks to be up in the system. They thought that this will be very the water will enter and this will be very soft and then can be dangerous. But after seeing a lorry on the top, no more discussion, and the rest of the works got gone. This is how it looks after 1 year, and this is how it looks now. You can see this is from the water and from the footpath, and you can see that here there is no erosion on the bottom, but now the wood is beginning to decay. This is 12 years old, so now is at 14 is when the wood decays totally. Well, totally not, but begin. So you can see that everything is stable. Another sample. This is a house around a city. The cities have the effect of make peak flows. Very important. You can see this is a fencing of the house has been destroyed, part of it. Here is a hole, and what we have done is study what's going on there, what kind of speed and tension we have. When we know the data, we make a design and we go on with the jobs. And here is the job going on, and at the end, and here you will see when the job is totally finished, one detail, and here some after 1 month and today. Today is again full cover of vegetation. You can see that here that he is eroding the other part, but this is also an objective because they want to make a park in this area. They need to increase the size of the river because well, the situation of this river, the quantity of water he catch is has been grow. So we need to work in the river in the same way. Another sample. This is here. There is a channel, well, a tube of wastewater and protected by rocks. So we take out the rocks. We protect with hydrophytes, with these plants that grows in the rivers, and we plant it. The objective of this job is two. One is make it more natural, and second, then they don't want to have too main maintenance. So you can see now with the trees totally developed, there is not so many grass on the bottom, and then the days they need to the attention they have to make here, the maintenance has been reduced quite a lot. Another sample below the cans here, you can see that there is a channel that in the old days, this channel goes directly to the river, but they transform it, and what they create is a system that is nearly without the slope. So everything grows here, and then when there is a flooding, the water don't have a space because it's full vegetated. So what we create is a kind of dams to concentrate the water in the center with different techniques. Here is the job, the way we do some of these dams. This is a photo of what's going on a few days after. And here is what it looks like. You can see that here is these plants here, well developed, salix in that case. And you can see that this really creates a line of water in the center of the river that makes that when the flooding comes, the flood can go through the area and also keeps everything in place. So we always work in great conditions to improve the quality of the rivers. Another example, this is a factory, is a minery. In 10 years will disappear, but now is someone select a bad place to be installed. And twice a year they get floodings. So we do a design to protect it. This area before the river goes in that direction. This area is an area that is from the river. So there is no problem if they flood it. So what we have done is make just a dam. A dam is done with some technical characteristics, with some engineering ideas, with the grass we use and the way to install it. This is our engineer, Jesus, who has done this design after the work done. And this is how it looks now. I think this has been done 6 years ago, and no more flooding events has been here at all. Another job, Sandilari, here is a rigid place that we we change a lot to return to a normal way. We want to create again the river. This is the wastewater. So of course this is not a way to manage this. So we put in another place. This is how it looks like. Here we install a fiber roll to be sure that the bottom of the river, the bank of the river is not eroded. And here we create fascines to facilitate the growing of the plants we install using material of the area. Here's what it looks like afterwards. And here there is a bridge, so we need to make a creek wall also here because this is very steep. And this is also something very natural. And of course, the way he changed the area is absolutely interesting. Another work here, we have a problem here because there is also a channel of water, drinking water, that is being eroded. Here you can see it's difficult to see, but here there is the pipe, and we want to protect the pipe. And what we do is here there is some trees that create problems, that are very invasive. So we take it out, and with the trunks of these trees, in that case is Robinia pseudocacia, that is a plant in Spain, we make a new creep wall to protect the area. And here is when we finish, and here is after 1 year, and today you can see any difference, but the problem is solved just working with the materials you have in the area. Here, of course, this is creating erosion in front, but there is no problem. You can see that we study that not just what's going on today, what will happen when we finish the work. And a final job here is a middle-aged town that people threw everything in the river from the old days, a lot of construction materials from centuries, and we clean everything, we install new soil, we protect this soil with a coconut blanket and with some vegetative fiber rolls in the front. And here's how it looks like after a few days. And here is also a view. You can see here there is the drainage of the storm water of all the town. And they have installed here rocks, of course, in a bad way, because they don't consider the transition erosion. So we make a system. Here there is some wood construction into the system, and here we install some fiber rolls with plants. So today, if you go there, you see a photo of something natural. So we make engineering, but it turns to landscape. Nobody knows that this is really artificial. It is not something natural. And that's all. I think that you enjoyed the presentation. In our webpage, you can have more information about solve engineering. And of course, we are open to help in anything that can be useful. And many thanks to invite me in this event. And I wish I contribute in something. Okay, thank you a lot.